Okay, today we're in section 8.2, linear equations and two variables. What this means is a linear equation, when you graph it, it's going to form a straight line. Two variables means that in these equations, you're going to have two variables, and in these equations, it'll be an x and a y. Now, yesterday we talked about how our x values are also known as what? Domain and input. X values can also be the input. And then our Y values are known as the range or the output. Okay, so different terms can be used for the variables X and Y. You're going to see a lot of dealing with that in this section. All right, so in the first example, what we're going to do is we're going to take this two-variable equation, 2x minus y equals 5, and we're going to test these solutions. All right, now these are ordered pairs, so which value comes first, the x or the y? X value comes first, and then your y. Okay, so that's just hopefully a refresher for you guys. So you're gonna plug in the 1 where x is in the equation, and the 3 where your y is in the equation. You start off by writing 2x minus y equals 5. Then you make your substitutions. 2 times 1 minus 3 equals 5. 2 minus 3 equals 5. And what's 2 minus 3?
Negative 5?
It's going to be negative 1. And does that equal 5? No, it doesn't. Okay, so the answer is no. Now I want you to test your solutions for the next two ordered pairs. Notice, look at this y value right here. What's this y value that I'm circling?
Negative.
It's negative. So what happens when you plug in a negative where there's already a negative?
Double negative.
Okay, so make sure you don't forget to do that. Go ahead and make your substitutions and test your solutions. All right, so once we make our substitutions to the second one, we have 2 times 4 minus a negative 7. My double negative changes to positive. 8 plus 7 is 15, so it does not equal 5. No. Now, on the last one, 2 times 9 minus 13, yeah, 5 does equal 5, so the answer is yes. Did y'all get both of those? Did you get them? All right, so testing ordered pairs to see if there is a solution to the equation. That's example 1. Now, in example 2, we're going to use a volcano example to basically test solutions. So now we don't have, for example, an ordered pair that we can test a solution. We're actually going to come up with our own order or our own domain or input value and figure out, we're just going to test the solutions. So let's go ahead and read the example. It's on page 391, or you can just listen. It says the Hawaiian volcano Mauna Loa has erupted many times. In 1859, the lava traveled 32 miles to the Pacific Ocean at an average speed of 4 miles an hour. So here's what it's asking us to solve. Okay, it's giving us this formula right here. So this isn't something that you have to memorize. The problem will give you a formula, and now we're going to take some values and we're going to test basically, okay, well, in this given amount of time, how far would it travel? In this amount of time, how far would it travel? All right, so the first thing we're going to do is we're going to make a table of possible solutions for the equation. We need 3 columns to the table. And now we need to consider which variable is going to be our input and which one is our output. And here's how we know. Whatever variable the equation is equal to, that is our output. Does that make sense? So that's why it comes second. That's why it comes after. T, whatever value we plug in for the time, that's going to affect how far the lava has traveled. Then our substitution is the equation. D equals 32 minus 4t. What it doesn't give us is it doesn't give us a domain or input value. So we're just going to make them up. 0, 1, and 2. Okay? 0, 1, and 2. So what we're going to do is we're going to take 0 and plug it in for t. We're going to take 1 and plug it in for t, and 2 and plug them in for t. We're going to substitute those values, whatever we get as an answer, that's our distance. So 32 minus 4 times 0, 32 minus 4 times 1, and 32 minus 4 times 2. I want you to go ahead and find your distances given those amounts of time. All right, so my distance, when it's just erupted, so time is 0. So when it's just erupted, what's my distance from the ocean? Well, it's 32 miles. Okay, I know that based on the example. Well, what about after the lava has traveled for an hour? 28 miles. Okay, so now it's getting closer. What about after 2 hours? 24. Okay, so I definitely see a pattern. Well, now let's look at question B. How long did it take the lava to reach the ocean? Okay, well, they want you to set it up as an equation. You could just basically keep counting. 3 hours would be 20, 4 hours would be 16. Do you see what we're doing? Just decreasing by 4 miles. They give us the equation, and they basically say, use 0 right from the time that it erupts. Okay, so at 0 it's 32 miles. So let's plug in 0 for my distance. Okay, because it hasn't traveled at all, equals 32 minus 4 times time, and time is what I don't know. How long does it take to make it that full 32 miles? All right, now you could do it one of two ways. You could subtract 32 or you could add 4t, but your variable needs to be on one side. So which way would you prefer to do it?
On the 0 side.
Okay, so we're going to go ahead and add 4t to both sides. All right, and we get 4t equals 32. And now how do we solve for t? Divide both sides by 4. All right, the reason we use the value of 0 for distance is because we want that starting point. Does that make sense? So anytime you solve a problem like this, your value is that you substitute is going to be 0. And then t equals 8 hours. All right, so that's it for example 2, just finding solutions. All right, now in example 3, we're going to get to the graphs. Now we're getting into, not saying that examples 1 and 2 aren't important, because they are, but example 3 and 5, really, those two examples are probably the most important for you to know in this lesson. All right, so you don't have to write this down. I just want to show you the graph of an equation with two variables. We know that that's your x and y. They represent the solutions of the equation. We call this a linear equation. So basically what you're going to see on your graphs is your potential solutions for that equation plotted in points. All right? And it'll make more sense in just a second. Now, the first thing that we want to do when we're asked to graph a linear equation is we want to set up an input-output table for the function. Okay. Well, we call this a function. We also call it an equation. It's basically it can hold both terms. We'll talk more about functions in a second, though. All right, so for now, we'll call this a linear equation. All right, so we have y equals 2x minus 1. Go ahead and set up this table. All right, sorry, wrong one. Okay, where you have your x, and is x your input or your output? Input. And you have your y values. Now, here's what they don't give you. They don't give you a set of x values to plug in. So we are going to use a standard set of x values to plug into these equations. Do you understand that? That we're making up these numbers. We're not getting them from anywhere, but this is a standard set of numbers that's oftentimes used. -2, -1, 0, 1, and 2. We do want at least 5 solutions being tested in this equation. So now, with these x values, we're going to do what we did in example 1. We're going to plug these x values in for x in the equation. So what would -2 times 2 be? -4. And what's -4 minus 1? -5. -5. All right, now, I don't need you to show your work as far as what you're substituting and multiplying. That would just be too much. Okay, I want you to go ahead and fill in the rest of this input-output table. Okay, so what's my output for -1?
-3.
Very good, my y value. What about 0?
-1.
Did y'all get -1?
Yes, ma'am.
Okay, what about 1?
1.
And what about 2? 3. Okay, so now these values form ordered pairs. I don't necessarily need you to write them out, but I do need you to understand that your x and your y value together form an ordered pair. So this is 1, this is 1, this is 1. How many ordered pairs do you have?
5.
You have 5 ordered pairs, and now you're going to plot them on the coordinate plane. Okay, so I just want you to watch this part. I'm going to have you do some graphing in the next lesson. All right, but look at your tables. What was the first input-output value that you matched up?
-2, -5.
-2, -5. So I plot my point. What's my next ordered pair?
-1, -3.
-1, -3. What's my next one?
-1, 1.
0,
0, -1.
-1. Then what?
1, 1.
1, 1. Then 2, 3. And notice when I connect the dots, when I draw a line through the dots, it forms a straight line. Okay, and it always will, because what type of equation are we graphing? A linear equation. All right, now the last step is going to be to write the linear equation on the graph. Okay, which is y equals 2x minus 1. And now we're done. So we started by making our input-output table, and then we graphed those ordered pairs, and that's how you graph an equation. All right, so this is a good stopping point. We're through example 3, graphing the linear equation. We'll talk more about this in the next lesson, but this will wrap up 8.2 part 1.